People like Heisenberg and Gödel, and what every one of those mathematicians and philosophers came to understand is that there's numbers can describe certain things, approximate certain things. But in fact, trying to put measurements and numbers on other things that are really unexplainable is folly. 300 years ago, they said that unexplainable realm was God. And people who attempted, in fact, to explain the unexplainable, who said, yes, I understand the unexplainable, were charlatans. They were the occults. They were the astrologers. They were the con men.
Alchemist.
Yes. Well, no, alchemists was, in fact, they believed that there was a way to transmute one metal into another. In fact, they always wanted to see if they can create gold. There's no reason, if you think about it, they recognize that one metal is different than another metal because it has some additional pieces to it. It has additional neutrons or protons or electrons. So because they thought it was a machine, they believed it was a machine, if I can take 5 protons and add 5, that gives me 10, I should be able to get gold. They'll move everything around inside these systems. The molecules transmute one molecule into another, and if this molecule I've transmuted it into is gold, I'm a rich man. It's back to money. But there's something strange happens. Isaac Newton says, this is really weird. If I want to push a ball on the table, I have to touch it. Maybe I have to blow on it. But I actually have to push one side of the ball or the book to move that side. I'm pushing here, and obviously this thing is what appears to us humans to be solid, so it moves as one thing. But the only way to get something to move was to touch it or put a force against it. Okay, seems to make sense. Everybody has that experience. I want to lift a glass, I lift it. If I want to push a ball, I push it. If I want to pull a ball, I pull it. But he recognized when the ball fell off the table, it went in a different direction. How's that possible? Nobody pushed the ball down. And he said, this is crazy. Why did the ball go down? I didn't push it. I just let it go. So someone's pushing the ball, because I know that I am confident that the only thing that gets something to move is with a force that pushes. So there's a force that's pushing the ball down. In fact, he called it gravity. He measured how fast it was pulled, but never was able to explain why it happened. How is it? What is gravity? It's this. Everybody says, well, why did the ball fall to the ground? Because gravity took it. But what's gravity? That's, as Feynman would say, that's the name of the thing. We have no idea what it is. This goes to Santa Fe. They were trying to explain the unexplainable. Can we measure? Can we figure out a way to predict the stock markets using these types of chaos complexity?
Before we get there, let's walk back through it. Let's go back to Newton.
Sure.
Pre-Newton and then Newton. What did Newton solve that for millennia up to Newton had not been solved? And then I want to go forward all the way to Santa Fe, what they were trying to solve. Let's start with just 2 or 3 of the basic guys, but let's go with Newton. What pre-Newton, it was what? And then why is Newton such a
genius?
In such a in the, I think mathematically they told me one time, or I've seen there's been 115 billion people roughly that have lived on the earth. And of that 115 billion, Newton.
Are you sure that's a number? That sounds a lot very high. We only have 7 now.
I think in the history of the earth, I think I'll pull up the stat for you, but I think it's 115 billion people. They figure
that probably is inflation. That's why you
have lived on Earth. But he's one of the handful of the most important. What did he solve for? Why is he so important for how we live today? And then we want to go through Leibniz and the other 2 or 3 other major ones to get us to Santa Fe.
Well, it's a long journey.
This is the heart of what we're trying to do.
Let me take a bit of a detour just a second. What if you went to high school and the last year in your high school you took calculus? So Isaac Newton sort of invents calculus. Well, that sounds invents, mathematicians.
To torture seniors in high school before they graduate.
Yes, but obviously, no, yes, the answer is yes. Certain people could never do calculus.
Why is that? Why is calculus why is that the dividing line between, to me, people who can handle that and can go on to do certain things, and people just hit the wall, even if they know math? It seems to me that that calculus is the thing that changes. It bridges. That's because it's about the theory of change and the theory of how things change.
It's a great question. But in fact, what calculus does is it's somewhat philosophical. That's why mathematics is Newton wasn't a mathematician, he was called a geometer. That's what they used to call themselves. They understood geometry and numbers. But there's an old conundrum where it says, during Pythagoras' days, Zeno's paradox it's called, where they said, well, if the wall is 2 feet away from me, and I take one step that's halfway to the wall, that'll be 1 foot away. And if I take another step that's half again, that'll be half a foot away, and then a quarter of a foot. I could walk forever but never touch the wall. Doesn't sound realistic, doesn't make any sense in our real lives of the physical. But what Newton understood is many problems were like that. Many things approached the wall, or in calculus, approached the limit, but never really reached it. So he said, it's okay, you don't have to reach it. We can do lots of the mathematics as if it was so close it was almost there. And we could do lots of mathematics almost being at the limit. And this is really important, Steve, for today. Because most of the science up until today was things that are starting to approach the limit. You were taught in high school that if you had 1 divided by 0, if you remember your high school algebra, you were told, what's the answer to that? Is there an answer to 1 divided by 0? No, if you were in high school, I'd say, stay away from it. It's the boogeyman. You could write it down as it's undefined. It's not able to be determined. There's a bunch of things. But in fact, 1 divided by 0 is a strange things happen. It's a world of the strange. And what I'll explain to you after is that when you get 1 divided by 0, you get into a world we don't know what happens. The answer is it's not explainable. We can call it things like undetermined. We can have a convention to say it's X, Y, or Z. But in real life, we don't know what happens when you are actually at the limit. So Newton thought the same concept, is that the limits were God. You got close to God, but you can never be God. He had this sort of religious interpretation.
Okay, I want to go back to Newton. Why is Newton such a big dividing line in mankind's history? What is it about Newton? What is it about what he's trying to solve? What did they not know beforehand? And because we live to a degree in a Newtonian universe, although I realized later subparticle atomic physics, but at least for a while it was Newtonian. So what's the dividing line? Why is he so important? Why is he an inflection point in mankind's movement from the swamp to the stars?
It's a great question. Stars was by Kepler. What Newton starts to allow us to do is to make accurate predictions. Remember that we've talked about that with money, about the things in our physical world, how cars, he didn't have cars, how horse carriages moved, how bowling balls moved, how pool cues and pool table balls.
Had people tried to solve that before Newton?
Many.
Tried it? Heraclitus or Plotinus, Pythagoras had these greats that we hear about. Had they tried to solve the same problem?
Not the same problem. They try to, again, what Pythagoras does, he starts to figure out this relationships in triangles. For example, everyone knows the a squared plus b squared is equal to c squared. That Pythagorean theorem, which is basically says these shapes in a triangle, each side of the triangle has a fixed relationship with the other two sides. That's strange. He knew, again, but it was all numbers. This was a system of things in the physical world, and Pythagoras says we can start putting numbers on things that help you predict how they will behave. You can add two triangles and make a square, some different shapes. They were looking at geometric forms. Newton says, well, I want to know how planets move. I want to know how things around me move. Can we find formulas? Can I find formulas that explain what I see in the physical world, how physical things interact and how they describe one another? Again, the fact that two things, two solid masses, for some very strange, unknown reason, unknown today, attract one another, no matter what they are. People have seen the experiment. You hang something, two little metal balls from a string, they move towards each other. In fact, they move towards each other was very specific. So when you drop the ball to the floor of this room, Newton says, in fact, the room came up a bit to meet the ball. The room moved. It's imperceptible. You can't really perceive that motion, but they attracted each other with certain ratios. So he started to be able to measure things in the physical world. And that was great advances. It also, now you wanted to move very quickly. Unfortunately, most people, especially in the 20th century, 19th century, said, well, like Newton, let's measure everything. Let's measure people's behavior. Let's measure their psychology. Let's measure their health. You go to we could have my blood test. Let's measure everything. We measure Wall Street.
Their voting habits.
Measure, measure, measure. Can we put a number on how much I care for my wife? Can I put a number on how I feel? And we tried, unfortunately, we try to mathematize the finer things in life, and then recognize that there's things that unfortunately just fall outside. Schrodinger wrote a very famous book about what is life. He was trying to figure out a way, can he describe the difference formulaically between things that are alive and things that are dead? The answer is no. The things that are alive in my world are miracles. Not magic. Magic has a bad connotation.
We
trying
don't
to
believe
hide
in
things.
you don't believe in the spirit or the soul. That's what animates people, is your spirit or your soul. That's
No.
Have you ever seen someone die? When they die, their spirit leaves.
Their soul leaves, no question. So in
There's
fact,
no question to you about
no
that.
question.
There's no question to you that there is some animating life force within us that leaves when you're dead.
Yes, in fact, I refer to the soul. This obviously is certain. The questions in the past, even
Because
during
people would normally think you were soulless. So,
Thank you.
But have you talk about you actually believe in it, and have done some thinking about it is pretty shocking in its own right, isn't it?
Well, again, mathematics. Leibniz thought.
We know Newton was at Cambridge, and he was the head of the math department, right? He's a professor, essentially.
Yes.
But Leibniz, was Leibniz a German professor?
Yes, but what Leibniz said is the soul is so strange because God took chemicals, which is simply the material, like tables, and he somehow made this material able to have a thought. How strange is that? Not only does it have a soul, but some way it was put together that this material substance is able to think. So when you say to me, it's obvious to everyone that there's such a thing as a soul. Now, if you're part of the Charlatanville, you'll try to explain it to people. The soul I describe as the dark matter of the brain. Why is it dark matter? Because in high energy physics nowadays you hear terms of dark matter, dark energy. Again, terminology. It's a complicated term. Why is it dark matter? Because we can't see it, that's all. What do you mean you can't see it? Well, somehow we see something moving towards this area of darkness. I can see this thing. This appears to me to be empty. It's just black. But I see it being drawn this way. So I say, well, I know if this were matter, that would follow that equation. If this was solid, it would explain the way this part